Right, we are back with some quick math. We are doing some number patterns. So grade 12s, you are dealing with sequences and series. But the question that is there is grade 11 content, but you could also be asked on it. So we're just going to deal with it for a quick second. Um, the first part of the question says determine the general equation or the nth term of the sequence, and how we go about that is first by finding the difference of the terms. The reason we do that is so that we can identify what kind of sequence this is, because they don't tell us. Okay, so we'll say from year to year, you had to add one to get from the first one to the second one. From the second one to the third one, you had to add three. From the third one to the fourth one, you had to add five. All right, so that's easy enough to see. But let's just talk about where these values actually come from. So what we did was we took consecutive terms. So we took this one, and we subtracted because we're finding difference. Difference means subtraction, and we're always dealing with consecutive values or consecutive terms. And we'll take the second one minus the first one. So we said 3 minus 2, and that's where we got this plus 1. Okay. Similarly, to find the difference between term 2 and term 3, we took our third term and subtracted the second term. So we said 6 minus 3, and that's where this 3 came from. And then also for the last difference, we again took consecutive terms. So we took the 11 and we subtracted the 6, and that's where our 5 came from. All right, so what have we discovered by doing this? We discovered that our first differences are all different. Okay, so we know that this is not a linear or a arithmetic number pattern. So we need to look at our differences, and we see something interesting because there is a constant difference between our differences. So from year to year, you have to add 2, right? So what we did again, consecutive ones. So it's 3 minus the 1 gives us that plus 2 that I've written down there. And then also from term or the 3 to the 5, you have to add 2. So what we notice here, these values are the same. Okay, great. So this tells me in our first level, there wasn't a constant difference, but in my second level, there is a constant difference. Because there's a constant difference in our second level, we know this is this is a quadratic number pattern, right? And because it's quadratic, it will be in the form Tn equals an squared plus bn plus c, right? We know quadratic refers to squares, so there's our square quadratic number pattern. Okay, so now the only thing left to do is to figure out what this a, b, and c values are. Right, so hopefully we remember when we have a quadratic number pattern, there are three equations that fit, right? The first one being 2a equals to something. We'll figure out what that something is a bit later on. 3a plus b is equal to something, and a plus b plus c is equal to something. These you will need to know off by heart. They won't be on your formula sheet, so make sure you remember them. Okay, so what we are going to do is this 2a, our first equation, it is going to equal to, let's maybe just change colors here for ourselves. Okay, that 2a is going to equal to this value. So our second difference, which is our constant difference, goes in over there. Our second equation, 3a plus b, we'll take the first value of the first difference, and that one will go in over there. And our last equation, let's try and get this 2 here. That last value in our or that first value of our sequence goes into our last equation over there. So make sure you know these equations and what they will equal. So let's add our values in here. 2a was equal to 2, 3a plus b was equal to 1, and a plus b plus c was also equal to 2. So now we need to solve these equations, and we start with the first one because that one has only one unknown. So in order for us to get a alone, we are simply going to divide both sides with 2, and that will tell us a is equal to 1. All right, let's go to our second equation now. We know the a value, so we'll substitute that. So a is 1, so it's 3 times 1 is still just 3, plus b is equal to 1. So we'll do some manipulation. We'll subtract 3 on both sides, so b would equal to a negative 2. And then we go to our last equation, do our substitution. So that's a 1 plus a minus 2 plus a c equals to 2, and c will equal to, so 1 minus 2 is minus 1, add 1 on both sides, and that will give us a 3. Now that we have our a value, our b value, and our c value, we can go back to our general equation and substitute. Right, so let's write this down. We'll say that Tn is equal to a, which is 1 n squared, plus b, so b is minus 2n, plus c, so it's plus 3. So here we have our general equation of this quadratic number pattern.